second level 3 problem. We've got a similar thing. We have strontium ions in solution. We need to find its concentration when it's already saturated, but it has 0.0250 moles of sodium carbonate added. Right? Now, even though this is describing a situation where it sounds like first we have the saturated solution, then we add some additional carbonate, you will get the exact same answer if you picture it the other way. That first we have 0.025 moles of carbonate waiting, and we add the strontium carbonate and it gets saturated. It's because equilibrium is something called a state function. It doesn't matter what direction you get to it from, you end up with the same answer anyway. This one, by approaching it this way, is easier mathematically than if we were to put concentrations in everywhere for the initial state and then change it and make it shift backwards. So the method works no matter what. That initially I take my 0.025 moles per 1 liter, and that gives me a 0.025 molar concentration. And I pretend that it's before I add the solid strontium carbonate, so my strontium ion is 0. So it's going to be plus x and plus x, because this is in a 1-to-1 relationship, 1 strontium for every 1 carbonate. And my equilibrium concentrations are shown as x and 0.0250 plus x. Well, as you can imagine, so we take our Ksp expression, which is the 1-to-1 for the concentrations of the ions. We substitute in our equilibrium numbers, and I know the Ksp already given to me in the table. And once again, we're able to say we can ignore the plus x. Right? It's insignificant compared to the 0.025. So when we evaluate it without having to go through the quadratic, we find out that the concentration of strontium is 4.4 times 10 to the minus 9 molar. And again, you could double check and see that if I took this number and I added it right up here, after rounding, I would end up with the exact same number, 0.0250. Because look at that, negative 9, this has got 8 zeros before you see the 4. So it wouldn't show up until somewhere around here.